Hello students, in the previous section we have discussed the various units for measuring distances. Now in this episode we are going to discuss the methods to measure distances, right? I'll start with a very simple illustration. Suppose I need to measure the length of this marker. So what I do is I'll make use of an instrument known as a scale, that is a ruler, so I can directly measure the length of this marker, isn't it? If I wish to measure the height of a room or the length, breadth, the dimensions of a room, then also I can simply make use of a direct method by using measuring tape. But if I intend to measure the distance of a star from the Earth's surface, then there is no such direct method. In such a scenario, we have to make use of some indirect methods. In this episode, we will be discussing certain indirect methods for measuring distances. Look, we have talked about some units of distances which are used for measuring extremely small values, like the size of an atom, the size of a nucleus. Now just imagine the gas molecules, atoms, they are invisible to us. We can't see them through naked eye. And we are talking about the composition of that atom, that is nucleus, the size of the nucleus. So the thing which is invisible to us, we are going to find the dimensions of that thing. So no direct method can be possible over there. So there we make use of indirect method to find such distances. So indirect methods are used either to find huge distances, astronomical distances, or it can be used to find atomic distances, right? So let's start with a very simple concept which you have done in your junior classes as well. We'll start with echo or reflection method. Echo or reflection method. Reflection, you are all aware of it, right? Whenever a wave is, it can be a light wave, it can be a sound wave. Whenever wave travels and its path gets obstructed by an obstacle, then what happens? It will bounce back into the same medium. That's reflection, the phenomenon of bouncing back of light wave or sound wave into the same medium. That is reflection. So here we'll start with a very simple example. So first we will try to discuss echo or reflection method. So there are various categories. First, it can be used to find out the distance of a distant hill by using a gun and firing a shot from the gun. We'll discuss it. Then we'll make use of sonar, sound, navigation and ranging, radar, radio detection and ranging, then laser method. All those are based on echo or reflection method. So let's start from the first one. To find out the distance of a distant hill. Suppose this is a distant hill and this is an observer over here at a very large distance. This is an observer, right? He shots a fire, he shots a bullet, right, from a gun. So at the instant t equals 0, this is initially. Obviously, the sound waves so produced will travel this distance, A to B, and after traveling this distance, it will get reflected from this obstacle, which in this case is a hill, and it will come back. So, if the mean distance of this hill from the observer is taken to be x, then the total distance covered by the sound wave is, during the entire journey, to and fro, that is 2x. Suppose t is the time that has elapsed between the instant of firing the bullet and the receipt of its echo. So t is the time interval between the instant at which the fire is shot and the instant at which its echo is heard by the observer, right? So t can be experimentally noted down. So we are aware of the simple formula, distance is equal to speed multiplied by time. So total distance covered during time t is 2x. Speed of the sound wave, that is v, and time that has elapsed is t. So x would be equal to v into t by 2. So noting down the value of t, and we are aware of the value of v at ntp, the speed of sound wave is about 332 meters per second, right? So substituting the value of v, noting down the value of small t in this particular equation, you can easily get the approximate distance of that distant hill. So it's a very simple method based on echo, or it is also known as reflection method, right? Let's discuss some other examples as well. Laser. Laser, it stands for light amplification by stimulated emission of radiation, right? It basically is a source which emits highly intense, perfectly parallel monochromatic beam of light. Monochromatic means emitting light of single wavelength, right? So laser stands for, the acronym laser stands for light amplification by stimulated emission of radiation. It is a source which emits highly intense, coherent, perfectly parallel monochromatic beam of light. I mean, the light so emitted by this, it can travel far away without its dissipation. So it can travel very far away distance. So this technique is very much used in finding the distances of astronomical objects, right? So suppose this is Earth, this is Moon. We need to find out the distance of Moon from the Earth. So what we'll do is, we can make use of the laser method. So, laser is sent from this particular point. So it will travel along the straight path. And then after getting reflected from the lunar surface, from the surface of the Moon, it will reflect back and it will be detected by a detector, right? Suppose at the instant of sending that laser beam, t equals to 0 and t equals to t, that is t be the total time that has elapsed between the instant of sending the laser beam and its reception after getting reflected from the lunar surface, right? Laser, it's an electromagnetic, it's a source of electromagnetic wave, so it travels with speed c in air or vacuum. So again, making use of the same formula, distance is equal to speed multiplied by time. So what is the distance covered by the laser beam during time t? 2x. C is the speed, and suppose x is the distance. So total distance covered is 2x. With what speed the monochromatic beam is traveling? It's an electromagnetic wave, so its speed is c. C is the speed of light or any electromagnetic wave. And what is the total time taken? T. This can be experimentally found out, right? So x would be equal to c into t divided by 2. We know the value of small c, that is 3 into 10 to 8. So knowing the value of t experimentally, substitute this value, and it is very helpful in calculating the distance of Moon from the Earth. For your knowledge, I must share this information with you that a laser beam takes about 2.6 seconds to get reflected from the Moon and reach back the Earth's surface. 2.6 seconds. So students, substitute the value of t as 2.6 seconds, c as 3 into 10 to 8 and solve it. You will get the distance of Moon from the Earth. In kilometers, the distance of Moon from the Earth is 3,84,000 kilometers. I repeat, it is 3,84,000 kilometers. So it can be written as in meters as well. 3.84 into 345, 10 to 8 meters. This is the distance of the Moon from the Earth, and it is measured by indirect method, which in this case is the laser method, which is based on reflection, right? So continuing with the reflection method, let's discuss some other example as well. The reflection method can also be used to detect, or rather to determine, the thickness of a matter sheet. Right? It's again a very interesting topic. So this is the third. This is suppose a matter sheet. This is a matter sheet, and this is one of the face, and this is its opposite face. This is point A and this is point B. What we do is a probe wave, that is a signal that can be in the form of a pulse, radio wave pulse. It is sent from point A, and after getting reflected from the opposite face, back face, it will come back, say at point C, right? So suppose the thickness is X and the time can be easily noted down. Suppose T is the time during which the probe is sent and again it is received back after suffering reflection from the back surface of this matter sheet, right? So again, using the same formula, distance is equal to speed multiplied by time. So distance is 2x. 2x is the total distance covered by the radio wave pulse in time t. Radio wave, it's an electromagnetic wave traveling with the speed of light into t. So x would be equal to c into t by 2. So this is another indirect method to find out the thickness of a matter sheet using echo method or using reflection method. It's all indirect methods, right? Another example. Let's take another example. Okay. Let's take the example of SONAR. SONAR, you're aware, it stands for Sound Navigation and Ranging. Sound Navigation and Ranging. Some ships are fitted with this sonar system, sound navigation and ranging. It makes use of ultrasonics. It makes use of ultrasonics, right? Ultrasonic waves. So basically, it is used, sonar system can be used to determine the distance of submerged rock or submarine. So I'll give you an illustration again. This is suppose the ship which is fitted with sonar, and at a certain depth, suppose this is a rock which is submerged. This is a rock which is submerged. It can be considered to be a submarine as well. Suppose there is a sonar system fitted in this ship. This is a ship. Now, we need to find out the distance of the submerged rock or submarine. So what to do is, ultrasonics are sent from this position. When its path gets obstructed by this particular obstacle, so it will get reflected back, isn't it? The instant of time, or rather the time that has elapsed between the instant at which the ultrasonic is sent and the instant at which it is received back, that can be easily noted down, which is considered to be time t. And suppose the distance which ultrasonic wave covers is x and x, 2x, total distance, right? So again, using the same formula, distance is speed into time. Total distance covered is 2x. Speed with which ultrasonic wave moves is v. It's not an electromagnetic wave, so its velocity is v. And total time is t. So again, x can be easily determined by using this formula. So x is the distance of that submerged rock or submarine from the ship. So this is again an indirect method which is very, very useful in the concept of sonar. The same concept is made use of in radar as well. Radar, it stands for radio detection and ranging. It stands for radio detection and ranging. It makes use of radio waves, which again are electromagnetic waves. In Air Force stations, radars that is equipped, the Air Force stations are equipped with hi-fi radars, right? And they keep on sending radio waves. So when an intruding aircraft comes, the radio waves get reflected from that intruding aircraft and they are received by the detector. And by using the same concept, the distance of that intruding aircraft from the radar can be easily calculated. And you'll study in later section by using Doppler effect. It can also be determined from which direction that aircraft is coming and with what speed the intruding aircraft is approaching or receding, right? Anyway, that will be discussed later on. Here we will be restricting ourselves only for finding the distance of that aircraft, right? Suppose this is a radar. This is suppose a radar, right? It is emitting radio waves and this is an intruding aircraft. So when the radio wave gets reflected from this intruding aircraft, suppose the distance of that aircraft at that instant is x. So again, using the same formula, distance is equal to speed into time. This is the formula which we are using. Suppose t is the time during which, or t is the time that has elapsed between the sending of the radio wave signal and its reception by the detector, right? So t is the time. With what speed the radio waves travel? With the speed of light. It's an electromagnetic wave. What is the total distance covered by this electromagnetic wave in time t? This is x plus x, that is 2x. So again, x equals to c into t divided by 2. So this is again an indirect method which can be used to determine the distance of that intruding aircraft, right? And I've told you, by using Doppler effect, the velocity of the intruding aircraft can also be determined. And it can also be determined whether it is approaching towards us or receding away from us, right? So these are some of the indirect methods which are based on reflection. There are some other methods of measuring distances as well. That also we'll discuss. That comes under triangulation method, right? Let's discuss that also. B is triangulation method. In triangulation method, we will make use of trigonometry, the measurement of the three angles of a triangle. That's trigonometry, right? So let's make use of triangulation method so as to find the distance of an accessible and an inaccessible object, right? It's very simple. So we'll divide it into two parts in order to find the distance of accessible objects. Accessible means the distance of that object from the observation point can be measured easily. That is an accessible object. Like this is the object. And suppose its height is to be determined. This distance is known, there is an object. Its height is to be determined. It can be considered to be a pole. Its height h is to be determined. Its height is h. Now this distance is known. This is the observation point. And this is known distance. Remember, for accessible object, the distance of the observation point from the object can be easily found, or it is known one. So here, this angular elevation can be easily calculated. And this angular elevation can be easily calculated by using an instrument known as sextant. It is an instrument which can be used to determine the angular height, or rather this angle of elevation, right? So theta can be experimentally determined. Now what to do is, if you consider cot theta, it is based by perpendicular, x by h, right? So base is x, h is, so what you get is h, it would be equal to x by cot theta. This is the formula. By substituting the value of theta over here, it can be easily determined by using sextant. X is known to us, so the height of that object can be easily calculated, right? This is to find out the height of an accessible object, right? Now in the second case, let's try to find out the height of an inaccessible object. Let's try to find out the height of an inaccessible object. Inaccessible object means the distance of that object from the observation point can't be determined. Let's take an example of a tree. The height of a big, huge tree is to be found, and it is on the opposite bank of that of the river. So in such a case, the distance of that tree from the observation point can't be measured, so it can be categorized under the inaccessible objects, right? So for that, what to do is, suppose this is the height of the tree, h, this is the width of the river, and this is a point on the other side of the river, right? A and B are the 2 points on the opposite sides of the bank of the river, right? This distance is not known. So placing sextant over here, we can easily find out this angle of elevation. Let us consider this to be theta 1. Now what to do is, this is another observation point. The sextant is placed slightly a distance behind this. So this distance is known to us. Now from this point the angle of elevation can be easily calculated. So suppose this angle is theta 2. So theta 1, theta 2 are known ones. That is, the value of theta 1, theta 2 can be experimentally determined by using the instrument known as sextant, right? X is also known to us. These are the 2 observation points. The distance with them can be easily found. So h is to be found using the value of x, theta 1 and theta 2. Now what to do is, let's consider cot theta 1. It is base over perpendicular. So it is AB divided by h. That is, AB may be written as h cot theta 1. It's fine. Let's consider this bigger triangle, cot theta 2. It is again base over perpendicular. Base is, suppose this is C, suppose. So AC actually. So let us consider this big triangle. So cot theta 2, we consider BC, right? Base over perpendicular, that is h. So which implies that BC is equal to h cot theta 2. Am I clear? Now look at the diagram. BC minus AC is equal to x. It's very clear. BC minus AC is equal to x. Substitute this value of AC and BC over here. So what you get is, h can be taken as common. Cot theta 2 minus cot theta 1 is equal to x, or h is equal to x divided by cot theta 2 minus cot theta 1. So this is the mathematical expression in which if you substitute the value of theta 1, theta 2 and x, you can easily get the value of height of that inaccessible object. So this is again a very simple indirect method for measuring the height of an accessible or inaccessible object by using sextant and using triangulation method. So students, I hope whatever indirect methods we have discussed in this session must be very clear. In the next session we will continue with some other indirect methods, right?